Today we'll learn about the angle of elevation and the angle of depression. So the angle of elevation and depression are just fancy words for talking about how to construct pictures or diagrams. So the angle of elevation is if I have a horizontal piece of land or something, the angle of elevation is how far up am I lifting my gaze, for example. The angle of depression is how far down I'm going. So for both of these, you need to start at a horizontal. Elevation is up, like an elevator, you're going up, and depression is you're having a low day or you're having a bad day, so you go down because it's negative or feeling bad. And there are ways that you can remember it. So how do we work these types of things into problems? Well, let's have a look. So from a point 40 meters from the base of a lighthouse, the angle of elevation to the top of a lighthouse is 20 degrees. Okay, so the very first thing is how tall is a lighthouse? I want to actually draw this in. So I'm not a very good drawer. This is like my little lighthouse, and there's a little thing there, and it's got a whole bunch of light coming out. All right, so this is my lighthouse. I want to know how tall the lighthouse is, so that's like my X. I also know that from a point 40 meters from the base of a lighthouse, so this is the base, and it's out across, so that means this length along the bottom is 40 meters away, and the angle of elevation to the top of the lighthouse is 20. So this here, it's going across, and then it's up 20 degrees. So I now have a triangle. All right, so if we're without all the fancy drawings, it just ends up looking like this. So I got 40, I have 20 degrees in there, and I have X like that. So we need to now draw up or label our diagrams so we know whether to use SOHCAHTOA or sine cos or tan. So do I have a hypotenuse? I don't. I do have my adjacent, and I do have my opposite. So here I go and find that I want to use my tan. So I have tan 20 is equal to my opposite, which is X, over my adjacent, which is 40. So that means my X is going to be equal to 40 times by tan of 20. So that's just multiplying the bottom value of my fraction up to the top. And I've just swapped the sides around because it doesn't matter. You have equal signs, so I could have my X on 40 on the left hand side and my tan 20 on the right hand side if I wanted. It doesn't matter. So X is equal to 40 times by tan of 20. So put that in the calculator, and I get that X is equal to 14.56 meters tall. All right, so I know the lighthouse is 14.56 meters tall. Okay, cool. So we've just used our angle of elevation there to problem solve. What about using angle of depression to problem solve? So a watchtower is 45 meters tall, right? It's a big watchtower. Someone inside the watchtower looks down at an angle of depression at 40 degrees. So here their horizontal would be their normal, but if they're looking down, it is an angle of depression, and it's down 40 degrees. And they see a ranger, so that's this little cool guy here. He looks pretty cool. And how far away is the ranger from the watchtower? So that there is your X. You're wanting to know how far away he is. So that's X meters. You also have 45 meters tall, so that we know that that length there is 45. So here, I guess the important bit is to note that we do not have any angles inside my right angled triangle. Alright, so our first step is to find an angle inside the right angled triangle. Now if I have 40 to this part, how many degrees are there in a total up in this part? Well, if that's going out horizontal and that's going down vertical, that means there's 90 degrees in total. So 40 plus something has to give me 90. So that's going to be 50. So the way I worked that out is that is 90 minus 40, which equals 50. So now I know that this angle is inside, I'm going to redraw my triangle just to make life a little bit easier. So I know that this is X, I know that this up here is 50, and I know that this height there is 45. I also know that this is a right angle because it's tall, so it's vertical, and then horizontal because it's how far out, so it's along the land. Okay, so let's have a look at our labels. So we have 50 degrees, so X is our opposite. Our 45 here is our adjacent. So in this now, again, we're going to use tan because we don't have the hypotenuse. So I'm going to have tan of 50 is equal to my opposite, which is X, over my adjacent. So that is my 45. So then overall, I have X is equal to 45 times by my tan of 50. I get 53.63. So in summary, the Ranger is 53.63 meters away from the watchtower. And that's it. That's angle of depression and elevation. So it's just about keeping in mind, am I going up or am I going down? And just thinking about, do I have all of my angles in a triangle in order to use my SOHCAHTOA memory trick?